In this video about braking distance, we start with a car moving at a constant velocity, but then all of a sudden a sloth falls out from a tree, and the car has to think about braking. However, it is moving at a constant velocity still, and only when it presses the brake will it start to decelerate. The distance travelled between here and here is the thinking distance, and that's the distance travelled whilst you're thinking to stop between when you see the stimulus of the sloth falling out of the tree and when you press the brake pedal in order to decelerate, slow down, and eventually stop. Let's look at how this can be shown using a velocity time graph. So as we've just seen, we start with the car moving at a constant velocity, but then the car is going to brake, and it will slow down and eventually go to 0 meters per second. Let's add some numbers. So let's say the velocity is 6 meters a second. It starts at 0 seconds, presses the brake at 2, and stops at 3 seconds. So acceleration is change in velocity over time. So it's 6 meters per second divided by a time of 3 minus 2, which then gives 6 meters per second squared. So the acceleration or deceleration of this line is 6 meters per second squared. We can also use a velocity time graph to find out the distance travelled by the vehicle. And the equation is distance travelled equals velocity times time, which is the area under the graph. So what we can do is we can split it into two shapes, a triangle and a square. So with the square, it's 6 multiplied by 2, which is 12. And then for a triangle, half base times height. Height is 6, width is just 1 divided by 2, so 3. So total distance travelled is 12 from the square, 3 from the triangle, which then gives a total distance of 15 meters travelled from the start to the end. Thank you for watching today, and as ever, if you have any questions, let me know, and don't forget to hit the subscribe button. Bye bye.